Welcome friends to Lakshminarayan's YouTube channel. Please subscribe to this channel to get latest educational videos. The Indian Space Research Organization, ISRO, is the National Space Agency of India, headquartered in Bangalore. It operates under the Department of Space, which is directly overseen by the Prime Minister of India, while the chairman of ISRO acts as the executive of DOS as well. ISRO is India's primary agency for performing tasks related to space-based applications, space exploration and the development of related technologies. It is one of 6 government space agencies in the world which possess full launch capabilities, deploy cryogenic engines, launch extraterrestrial missions, and operate large fleets of artificial satellites. The Indian National Committee for Space Research was established by Jawaharlal Nehru under the Department of Atomic Energy in 1962 on the urging of scientist Vikram Sarabhai, recognizing the need in space research. INCOSPAR grew and became ISRO in 1969 within DA. In 1972, the Government of India set up a Space Commission and DOS, bringing ISRO under it. The establishment of ISRO thus institutionalized space research activities in India. It since then has been managed by DOS, which governs various other institutions in India in the domain of astronomy and space technology. ISRO built India's first satellite, Aryabhat, which was launched by the Soviet Union in 1975. In 1980, ISRO launched satellite Rupees-1 on board its own SLV-3, making India the 7th country to be capable of undertaking orbital launches. SLV-3 was followed by ASLV, which was subsequently succeeded by development of many medium-lift launch vehicles, rocket engines, satellite systems and networks enabling the agency to launch hundreds of domestic and foreign satellites and various deep space missions for space exploration. ISRO has the world's largest constellation of remote sensing satellites and operates the Gagan and Navik satellite navigation systems. It has sent 2 missions to the Moon and 1 to Mars. Goals in near future include expanding satellites fleet, landing a rover on Moon, sending humans into space, development of a semi-cryogenic engine, sending more unmanned missions to the Moon, Mars, Venus and Sun, and deployment of more space telescopes in orbit to observe cosmic phenomena and outer space beyond the solar system. Long-term plans include development of reusable launchers, heavy and super heavy launch vehicles, deploying a space station, sending exploration missions to external planets like Jupiter, Uranus, Neptune and asteroids, and manned missions to moons and planets. ISRO's programs have played a significant role in the socio-economic development of India and have supported both civilian and military domains in various aspects including disaster management, telemedicine and navigation and reconnaissance missions. ISRO's spin-off technologies also have founded many crucial innovations for India's engineering and medical industries. After 1945, important developments were made in coordinated space research in India by 2 scientists, Vikram Sarabhai and Homi Jahangir Bhabha. During the Prime Minister, Indira Gandhi, INCOSPAR was superseded by ISRO. Later in 1972, a Space Commission and Department of Space were set up to oversee space technology development in India specifically, and ISRO was brought under DOS. Institutionalizing space research in India and forging the Indian space program into its existing form. India joined the Soviet Interkosmos program for space cooperation and got its first satellite Aryabhatta in orbit through a Soviet rocket. Efforts to develop an orbital launch vehicle began after mastering sounding rocket technology. The S.L.Vs, first launch in 1979, carried a Rohini technology payload but could not inject the satellite into its desired orbit. It was followed by a successful launch in 1980 carrying a Rohini Series 1 satellite, making India the 7th country to reach Earth's orbit. R.S.1 was the third Indian satellite to reach orbit as Bhaskar had been launched from the USSR in 1979. Efforts to develop a medium-lift launch vehicle capable of putting 600-kilogram class spacecrafts into 1,000-kilometer sun-synchronous orbit had already begun in 1978. They would later lead to the development of PSLV. The S.L.V-3 later had two more launches before discontinuation in 1983. ISRO's Liquid Propulsion Systems Center was set up in 1985 and started working on a more powerful engine, Vikas, based upon the French Viking. 2 years later, facilities to test liquid-fueled rocket engines were established and development and testing of various rocket engines thrusters began. At the same time, another solid-fueled rocket-augmented satellite launch vehicle based upon S.L.V-3 was being developed, and technologies to launch satellites into geostationary orbit. The number of satellites eventually grew, and the systems were established as among the largest satellite constellations in the world, with multiband communication, radar imaging, optical imaging and meteorological satellites. The arrival of PSLV in 1990 became a major boost for the Indian space program. With the exception of its first flight in 1994 and two partial failures later, PSLV had a streak of more than 50 successful flights. PSLV enabled India to launch all of its low Earth orbit satellites, small payloads to GTO and hundreds of foreign satellites. Along with the PSLV flights, development of a new rocket, a geosynchronous satellite launch vehicle GSLV, was going on. A new agreement was signed with Russia for 7K.V.D1 cryogenic stages and a ground mock-up stage with no technology transfer. Instead of 5 cryogenic stages along with the technology and design in the earlier agreement. These engines were used for the initial flights and were named GSLV Mk1. ISRO was under U.S. government sanctions between 6 May 1992 to 6 May 1994. After the United States refused to help India with Global Positioning System (GPS) technology during the Kargil War, ISRO was prompted to develop its own satellite navigation system IRNSS, which it is now expanding further. In 2003, when China sent humans into space, Prime Minister Atal Bihari Vajpayee urged scientists to develop technologies to land humans on the moon and programs for lunar, planetary and crewed missions were started. ISRO launched Chandrayaan-1 in 2008, purportedly the first pro-Asian spacecraft to enter Martian orbit. India was the first country to succeed at that on its first attempt. Subsequently, the cryogenic upper stage for GSLV rocket became operational, making India the 6th country to have full launch capabilities. A new heavier lift launcher GSLV M.K3 was introduced in 2014 for heavier satellites and future human space missions.